Good day and welcome to today's class. My name is Oluwatomi Blessing Olalekun, the founder of Michael Labs, an online YouTube channel. All right. So for today's, we'll be looking into the concept of curved tangency. Curved tangency, all right. All right. So, but before we proceed, we all know that if we have a circle in this form, if we have a circle in this form, and if a straight line cut through the circle in this manner or touches the circle at any angle, these lines are said to be known as what? A tangent. All right. Yeah, that's a tangent. But in this particular scenario whereby we are having a circle in this form and we have an arc, tangential to it in this manner or in this manner. All right. So this first arc and this second arc are known as they are known as tangency. All right. So and that brings us to what the concept of what tangency. All right. Okay, we have three principles. Yeah, we have three principles of tangency. Okay. Yeah. The very first principle is principle of an arc on a straight line. Yeah, principle of an arc on a straight line. So what does this imply? Take a look at this scenario. So if I were to have this vertical line and this horizontal line, right? Then I have an arc cutting across it this way. Okay. So if I was told that the radius of this arc is radius 20 millimeters. Yeah. So as we can see, this arc is what line on a straight line here and also what and also a straight line here. So I don't know whether we've seen some components in our various homes, such as table, edge of a table, or edge of several solid objects. Yeah. So this portion is also known as what? Fillet. Is also known as what? A fillet. A fillet. All right. So how do I produce this option? I am going to apply this first principle of what? Of tangency. So what am I going to do? I'm just going to what? Produce that straight line, produce this. Then with my compass, with my compass, I'm going to measure radius of what? 20. I measure mark of 20 on my compass. I stand right here at this junction, all right, with my compass, with mark of 20 on my compass. Standing right in this junction, I strike an arc at the top here. All right. So with that same mark of 20 on my compass, standing at this junction, I strike another arc right here, as you can see. Okay. So what is the next procedure? The next procedure is this. Just follow me. With that same mark of 20 on your compass, stay right here where your arc intersects the vertical line here. Place the pin right here and what? Strike an arc in this manner. All right. With that same mark of 20, place the pin right here where the arc touches this straight line here. Strike another arc in this manner. All right. And with that same distance of 20 on your compass, stand at the point of intersection and what? And draw the what? The corresponding arc. And draw the corresponding arc. All right. So that is what the first principle is all about. Yeah, that is what it's all about. So we are actually going to apply principle in several examples here, which we are actually going to touch. All right, such as the light bulb. Yeah, this first principle will be applied therein. Okay, now let's move to the second principle. The second principle states that principle of what? External arc. Principle of external arc. That's it. The principle of what? External arc or external tangency, either of the two. Okay, so how do we deduce which arc is external? How do we deduce which arc is external? Okay, let me take it together. The third principle is principle of internal arc or internal what? Tangency. All right, that's it. So take a look at this scenario. I'm having a circle in this manner. I'm having another circle in this manner. Then I'm having an arc. Can you see? In this manner. Alright. So this particular arc, yeah. Then I'm having another arc right here in this manner. So this one will be denoted with arc 1, while this is denoted with arc 2. Alright. So on this simple drawing, I am having an internal and an external arc right there. Okay. So how do I deduce which of the arc is internal or external? Believe you me, for every question on curved tangency, it doesn't exceed these 3 principles: first, second, and third. Yeah. All you have to do is you need to be creative about it. All right. You need to know where to apply first principle, second principle, or what, or third principle. All right. And the very first process which you need to deduce before solving the question or before solving the problem is this: you must deduce which of the arc is external or internal. All right. Now back to this question on the board right here. So this arc on the top is internal arc. You'll be amazed. Why is it internal? Why this arc number 2 is what? Is external. Yeah. That arc number 1 is internal. This is what? Internal. Internal. Why this one is what? Is external. Alright? External. So as I was saying, you'll be surprised. Why will this be internal and why will this be external? Let me explain. Take note of this. You know that combination of several arcs, yeah, several arcs makes up what? Makes up a circle. Yes or no? That is it. A very big yes. All right. So now, if you take note of this particular arc here, this arc, as it is facing, if I'm going to make this arc a complete circle, what will I have? This arc as it is. I'm going to be having something like this. Yes or no? To make a complete circle, I'll be having something of this one. Yes or no? That is it. So that is the complete circle of this particular arc. If I were to make it what? If I were to make it what? A complete circle. So for this reason, take note of this. When I make this arc a complete circle, this circle is what? It is encamping circle R1 and circle what? R2. Yeah. This my arc here. By the time I make it a full circle, it's what? It encamps circle R1 and circle R2. That is, this first circle and second circle are inside this particular arc here. When we turn it to a complete circle. So for this reason, if you are to solve any problem and you trace out the arc to form a complete circle, first of all right, and the circles which your arc is touching are inside the complete circle of the arc you are drawing, then take note of this. That arc is what? Is known to be what? An internal arc. It is known to be what? An internal arc. All right. So now, for this second one, I said it is what? An external arc. I said it is an external arc. Why is it an external arc? If I'm going to make this second arc a complete circle, I will be having something like this, isn't it? The circle goes outside right here. So take note of this. When I make this arc a complete circle, the circle which this arc makes is what? Is outside these two circles which the arc is touching. Yes or no? Yes. So therefore, this arc is said to be known as what? External arc. Because what? By the time I make the tangential curve a complete circle, it is what? It is on the outside. Yeah. It is on the outside of the two circles which it is what? Actually touching. Alright. So that is that about that. So one thing I also want to call your attention to is this. In external tangency, we apply principle of what? Addition. Alright? While in internal tangency, we apply principle of what? Of subtraction. Subtraction. Alright? Where do we apply addition? How do we apply subtraction? Let me explain. Let me explain. Okay, now considering the chart on the board, all right? So remember this very arc at the bottom here. If I make it a complete circle like this, all right? This arc is what? It is external, right? It is external, and external is what? It is what? Addition. It is what? Addition. Okay. So where and where am I going to apply the principle of addition? Where and where? So just follow me. For this bottom part that we are applying addition, arc of radius 1 touches arc of small r1. Yeah. Big r1, that's the dimension for this arc. Alright, this arc that goes here, that's the dimension, big r1. Why? The dimension for the circle here, yeah, this area you are looking is actually a complete circle. Yeah, but they won't show you that it's a complete circle. So you need to deduce that also, alright? So why this area is also what? A complete circle. Yeah, it is also a complete circle, alright? So now, back to my explanation. So this arc at the bottom here is what? R1. Why this circle here is small r1 and this smaller circle here is what? Small r2. So big r1, yeah, for external arc, yeah, to get this external arc, big r1 plus r1, big r1 plus what? Plus r1. Okay, so the final outcome, this big r1 plus r1, its final outcome, whatever it is, I'm going to take the measurement, place it on my compass. Then after picking the measurement on my compass, I'm going to place my compass at the midpoint of this what? Of this small r1, because that is where I actually did my my addition. Alright? Then placing my compass right here, I'm going to strike my first arc in this manner. Okay? I'm going to strike my first arc in that manner. So on this other side, how do I get the arc that will intersect it? This same big r1 plus small r2. Big r1 plus what? Small r2. So whatever the outcome is, I'm going to pick my compass, measure that outcome, place it at the center of this small r2, then strike my corresponding arc. Alright? So after striking my corresponding arc, the next procedure is I will now pick I'm going to pick the dimension for my for my r1 itself. I will pick the dimension for my r1 itself. R1. Then picking the dimension for my r1 itself, I'm going to place the pin at this intersection here. Then, believe you me, I am going to get this curve here perfectly. I'm going to get it perfectly. Alright, that is for external arc. So if it were to be internal arc, yeah, if it were to be internal arc. So this arc at the top here, it is internal. Internal because if I make this arc a complete circle, yeah, it is going to It is going to encamp these two other circles, just as I explained earlier. Okay, so then I told you that in internal arc we apply the principle of subtraction. We apply the principle of subtraction. Okay, so what and what are we subtracting? For our internal arc, we denote it with capital letter R2. Okay, now capital letter R2 minus small letter R1. R2 minus R1. Yeah. Whatever the outcome is, you place your compass at this midpoint of R1 and you strike your first arc down here. Yeah. Why am I striking my arc down here? Those are the things you need to consider. Take note of this arc now. This arc here is actually facing this direction like this. So automatically, if I am to produce this arc, I can't place my compass at the top here and say I want to produce this arc. If I place my compass at the top here, this is what I will be having. Yeah, you can practice that on your paper wherever you are. So logically, I am to position my arc where it's going to be comfortable for me to get the perfect tangency curve. All right, that is it. So that's the reason why I'm placing my arc at the bottom here also, because it is from here I can produce an arc that comes in this manner. Okay, so back to where we are coming from. Big R2 minus R1, whatever the outcome is, measure it with your compass. Place your compass at the center of this big R1, which we deducted this from. Okay, then strike your first arc. Then big R2 minus minus small r2. Big r2 minus small r2. Whatever the outcome is, pick your compass, measure it out, and place your compass here, right at this junction here. Okay, then then strike the corresponding arc. Then if you are done with that, now measure your big r2 with your compass. Picking your big r2 with your compass, Place the compass at this point of intersection here. I'll show you what you will perfectly draw out this tangential curve. You perfectly draw out this tangential curve. All right. Before we proceed, I want to actually check, what we've actually assimilated before we proceed, because after leaving this particular slide, we have several examples here. Several examples. I'm going to lay my hands on several examples which you might come across. You understand? And which is going to be very useful for you. All right. And there are also tutorial questions for you to actually practice. Then, okay, so take a look at this. I'm having my first circle in this manner, my second circle in this manner. All right. So I'm having my arc right here, then another one right here. So arc 1 and arc 2, are they internal or external? This arc 1, if I make it a complete circle like this, can you see? It encamps the two circles. It is actually touching. Therefore, my arc 1 is what? It is an internal arc. All right? That's it. So for arc 2, if I'm going to make this arc 2 a complete circle, as you can see, it is also what? It is also encamping these two circles. All right? Therefore, my arc 2 is also what? An internal arc. That's it. My arc 2 is also what? It's also an internal arc. All right? So let's take a look at this also. Okay, so take a look at this arc 1 and what? 2. This arc here, is it internal or external? If I make this arc a complete circle, it is what? You can say that the circle is what? Is outside the two circles which the arc itself is what? Is touching. Therefore, this arc here is what? It is an external arc. All right? It is an external arc. So why this arc at the bottom also? If I make it a complete circle, if I make it a complete circle, as you can see. So it is also what? Outside the full circle. That's why the two circles which it is touching. Therefore, this arc is also what? An external arc. Yeah, it's also an external arc. It's also an external arc. All right. So kindly ensure you assimilate this. Yeah, those are the things you need to deduce before solving or attempting any problem on principle of the tangency. So I assure you, if you can deduce which arc is internal, which arc is external, then you are good to go. You are good to go. All right. So that's just it. So we are going to solve several problems together, starting from the basics. Then we keep stepping it up little by little, little by little. All right. Thank you.